Hello everyone, I'm Sanket Singh. I'm working as a software engineer at Google, and I would like to welcome all of you back on my channel and on this series of 10x Engineer Bootcamp, where we are going to learn programming starting from the very basics to the DSA part to the development part and whatnot. We already completed three different lectures on basic number systems, writing your first hello world, and discussing about operators in C++. In this particular lecture, we are going to talk about conditionals, and we are going to see what can be some awesome use cases for conditionals. Maybe you're someone who already knows about conditionals and might have already learned about conditionals. But I have taken an approach where I'm going to kind of like take a real life application of something like, let's say, an online streaming service like Netflix or something. And based on that, we will try to get a mind map into ourselves that okay, how if else or conditionals can be applied, what can be some real life situation in which actually conditionals are applied, right? So it's going to be a pretty interesting lecture, and definitely you will definitely learn something new. I have also inculcated some problem solving on very basic conditionals, so that's going to be pretty interesting for you as well. So stay tuned till the very last of the video, and if you have not yet subscribed to the channel, do consider subscribing to the channel. We are going to put some really awesome content here. So without any further delay, let's just start with the video. Having the knowledge of operators, variables is going to give us a lot of power. We are able to take user input, we are able to give user output, right? Now the thing is, can we do a bit more? A software, whenever you use a software like Zomato, Swiggy, anything, these softwares take a lot of decisions, right? For example, if you write correct email ID or password, then they redirect you to their homepage. Otherwise, they ask you to re-enter the email ID and password. This is a decision that they take, right? Based on what input you gave, they're going to do some processing and then actually make some decisions. So this is what makes programming languages special. Programming languages can make decisions. So we need to have some decision making capabilities, right? In order to take decision making capabilities, in a lot of languages, including C++, we have a concept of conditionals. We have a concept of conditionals, right? How conditionals are going to work is going to be really fascinating and really very interesting to understand, right? Okay. So let me show you an example. Let me show you an example based on which you will be able to understand conditionals better. So in order to understand conditionals, let's take a very interesting example. And as I said, conditional means decision making capabilities. So we want to have softwares that can make decisions based on what user is actually doing, right? So let me show you this very interesting example. This is the home page of Netflix. This is the home page of Netflix in mobile app. This is how Netflix actually is shown to you, right? There is a bunch of things, and what user actually does is user has to click on this sign in. The moment user clicks on this sign in, the user is redirected to this particular screen. The user is redirected to this particular screen. In this particular screen, the user is expected to put the email ID and password here. So this will be some user input. You are going to give some user input or take some user input. How Netflix is taking is not of our concern. It's like in programming, these notions exist that you are going to take some user input. And once the user input is done, you are going to click on this sign in button. We're going to click on this sign in button. The moment you click on this sign in button, there can be two things that can happen. There can be two things that can happen, which are actually these two things. Let me get some space here. Right. Okay. So there are two things that can actually happen, which is if the user gives correct user ID and password, user gives correct information, right? Then we are going to show this screen to the user where they can select their profile. If the user doesn't give correct ID as password, incorrect credentials, then we are going to ask for the credentials again. So here we took a decision, right? In the user life cycle, we took a decision. Here the only option was to show the user this sign up page or sign in page. Now based on what user will do here, you are going to show different screens based on that. If the user will give correct information, you are going to show this screen. If the user will not show correct information or not give correct information, you are going to show this screen. And let's say user gave this correct information, right? User gave this correct information and you actually landed up here. Now based on who is actually watching, that also helps us to decide a lot of things. Like in Netflix, you have different profiles, right? In one account, you can maybe have different profiles. Now based on those profiles, whatever profile I will select here. So I have, let's say, multiple profile, let's say of children and everything, right? So let's say someone can select any one of them. It's the decision that the user is going to take. So again, a user decision making capability is going to be given here, that whether the user want to get redirected to the children profile here, or the user wants to get redirected to Sanket's profile, right, or the Singh profile. So what profile the user wants to get redirected to is going to actually determine what is going to happen. Can I say that? So now let's say I consider two more cases. That let's say user selects Sanket's profile. Sanket's profile is selected, right? If Sanket's profile is selected, then maybe this kind of a page will get rendered based on what Netflix is going to recommend to Sanket, right? Let's say this is what Netflix is going to recommend to Sanket to show this kind of a page. Or maybe you are going to select the children profile. Or maybe you are going to select the children profile. Now, if you select the children profile, let's say you are going to get a screen like this. You're going to get a screen like this. So here we are making decisions. If I click on this, then we are going to get this kind of an interface. If I click on this, we are going to get this kind of interface. So based on what decisions you are going to make, you are going to get different type of interfaces. And these things exist in softwares. So these decision making capabilities are very easily handled by conditionals. And this is what we are going to actually understand, that what are conditionals, what are the different ways in which you can use conditionals, so on and so forth. So before starting the video, I would like to tell you about Algocamp.io. So if you are someone who is going to prepare for your upcoming coding interviews, you are someone who already knows basic problem solving and basic data structures and algorithms, and now you want to just kickstart your journey, or I would say level up your journey for your interviews in, let's say, next upcoming 3 to 4 months, where your target is to solve as many good hard problems as possible that are going to be asked in the top companies, then you can definitely go and check out the top coding interview problems course on algocamp.io, where we are going to solve more than 400 problems live as well as in hybrid recorded manner. It's a completely power packed course where we have picked not only just the data structures and algorithmic topics, but we have picked specific lectures where we are going to talk about specific techniques on every data structures and algorithm. For example, you can see there is dedicated lecture on problem solvings on arrays, then dedicated separate lectures on two pointers. Then you can see there is dedicated specific lecture on time and space complexity analysis and their problem solving. Then there is a bunch of revision lectures, because we know that recursion and backtracking still pains a lot of students. So there are a bunch of revision lectures for that. Then we'll talk about maths, we'll talk about modular exponentiation and matrix exponentiation, because a lot of questions around these are asked in online coding tests. Then we'll talk about problem solving around sorting, basic sorting algorithms, then dedicated problem solving around merge sort based problems, and of course not just inversion count but major wide variety of problems around merge sort, then quick sort and similar techniques around quick select algorithm, binary search, and you can see dedicated set of lectures around binary search on answer, minimax problems, binary search on real numbers and whatnot. Then linked list, you can see there are dedicated lectures on stacks, there is dedicated lectures on queues, binary search trees, binary trees, heaps, hashing, DP, tries, string algorithms, and all the different variety of DP along with graphs, DSUs, MSTs, and whatnot. And there will be a lot of mixed problem solving lectures that will happen. This is definitely not a lecture or not a course where we are going to talk about any cakewalk level problem or something. Everything that we are going to pick is going to be medium or lead code hard, or the problems are going to be from code forces or Codechef, right? this is something that you can definitely try and check it out. And you can use the code Algocamp 500 to get a flat 500 rupees off on this particular course. It's going to be something really power packed and something that you should definitely check it out. So if you are someone who is preparing for their coding interviews, do check out this course, and you can check out more things around algocamp.io. So now let's just move back to our video. So the first conditional statement that we are going to talk about is going to be if. If is a keyword. If is a keyword. And you might have seen people saying, right, that if it's, let's say, raining outside, take an umbrella. So you're able to take a decision that, okay, what's the weather outside? Is it raining? If it is raining, then you take an umbrella, right? So let's say, let's consider it with respect to the Netflix user journey. Okay. So let's say this is the Netflix homepage. Now we are going to, like, we can do a lot of things, right? This thing can be implemented in multiple ways. I'm just showing you something, right? That let's say from this particular page, you click on this sign in button, because there is only one action that you can do. Let's say sign in. Then you are redirected to a page like this, where you are redirected to a page like this, and so on, where you can give user ID, user input ID, user email, password, and then you can click on this sign in button, right? Now let's say if the credentials are correct, if the credentials, if credentials are correct, right? We will write some logic to check the credentials, but if the credentials are correct, then let's say we are going to render this screen, right? So we can make a decision that we are going to show this screen if and only if the credentials are correct, right? So this if keyword actually helps us in that. So if you see syntactical wise how you write the if statement, so you write the if keyword, then inside a pair of parentheses you write some condition, right? And then you put a pair of curly braces. Now what is this pair of curly brace actually going to do? At any point of time, whenever you see a pair of curly braces like this, in programming in C++, you will see it a lot. The pair of curly braces actually create a block. What is a block? Block is a collection of statements, right? So what it will do, it will create a if block. And inside this if block, we can write multiple lines of logic. And this logic will be only executed if the condition is true. For example, if I write if 5 is greater than 2, then we can say cout welcome. Okay, something random. So what will happen is, we will check, is 5 greater than 2? What is the evaluation of this expression? So again, whatever you write inside this condition, it is going to be evaluated as a boolean. So if you just write a 5, it is a boolean true, right? For 5 greater than 2 also, it's a boolean true. And if the condition is true, then you are going to immediately enter this block. All of the statements of this block is going to get executed. There can be multiple statements, for example this, and along with that you can do something like std cout, let's say 10, right? So you can have multiple statements. All of the statements one by one will be executed, right? All the statements one by one will be executed, right? But let's say if the statement is not true, let's say you do something like std cout start, and let's say do std cout end, and let's say you have a condition 5 less than 2. So let's see what happens. You go to this line, you are going to print start. You go to this line, you evaluate the condition. The condition is false. If the condition is false, then the whole block will not be executed, and we are going to come directly to the next line after the if block. Whatever is the next line after the if block ends, that we are going to actually execute, and in this prints end, and this prints ends, right? Whereas if the condition was greater than, then after start you check the condition is greater than, that means you're going to go inside the block. Inside the block you have welcome, you write welcome, you write 10, right? And this is the last statement of the block ends, and then you are actually going to print end, right? So this is what if conditionals are, that if the user has given the correct input, if the user has given the correct input, show them this screen, right? But the question that should come to your mind is, maybe the user doesn't give the correct input, right? Maybe something like this happens, that you are here, right? And the user clicks on sign in, the user clicks on sign in, you come here, now you are expecting the user to give phone number or email as well as the password and then click the sign in button. Then there can be two things, right? The credentials can be correct or incorrect. If the credentials were correct, we are going to go show this screen. But if the credentials are not correct, we are going to redirect them back to this particular screen, right? Right. So here the user journey can be divided into two branches. There can be two branches that can actually happen based on whether you have given correct information or not. So that means initially, if I have to write this conditional logic, I will say if user gives correct credentials, let's say somehow we will evaluate how the user gives correct credential or not. Somehow we will evaluate it. If the user gives correct credentials, then we can write show profiles. We can do something like show profiles. But what if the user doesn't give the correct credentials? In those kind of cases, you have else keyword that can help you, because now the condition here, the branch can be only two. Either the credentials will be correct or the credentials will be incorrect. That's it. There can be only two branches, right? So we can say if the user gives correct credential, show the profile, else. Now in else you don't need to have any condition. Show login page, right? So again similar thing happens. You just write the else keyword followed by a pair of curly braces. Inside these curly braces you actually create a block. This is the block of else. This is the block of else, right? In block of else we can have multiple statements. This condition will decide whether you want to actually execute the block of if or the block of else. So what will happen is, if let's say you have cout start, and let's say cout end, right? So what will happen is, you come to here, you print start, you go here, you check if the condition is true, if the user has given correct credentials. Let's consider the case that user gave correct credentials. So what will happen? You will go inside show profile page and this complete else block will be ignored, right? If this condition is true, we execute block number 1, or you can say if block, and this whole block will be just ignored. So after you show the home profile, or sorry, show the profile page, you're going to go directly to outside of if else, right? You're going to go directly to this statement. This else block will be completely avoided, right? So let me write it here. If condition is true, if block is executed, else block is avoided, and at the end of if block, code jumps to beyond else, right? That means from here you are going to directly come here. From here you are going to directly come here. This whole part will be avoided if this condition is true. But this can also change. If this condition was true, This can also change. This condition can be false. So if this condition is false, right? If let's say this particular condition becomes false, in that case, the complete if block will be avoided, because now the condition is not true. You cannot execute if block, because if block will only get executed if the condition was true, and hence you actually go to else block, and this else block will be executed line by line. So only line is show login page. So from here you actually show the login page, right? So we have made two branches in our code. So based on this condition, we can have two different set of pieces of code that can get executed, right? So let me show you a coding example for this. Okay, we say that bool is user are user credentials correct. Let's say the user credentials are correct, and I do something like this. Okay, let's say I say stdc in are user credentials correct. So I'm going to take input from the user whether it is true or false. Okay, so we'll say if are user credentials correct, we will say std out show profile page. Else you can write it in the new line, else std out show login page. Show login page. Okay, cool. Let's start. So now it's waiting for my input. So let's say somewhere we computed whether the user is able to give correct input or not, right? One second, let me run it again. Okay, so let's say somewhere we will be able to calculate whether the user credentials are correct or not. So let's say I say user credentials are true. So you see we are saying show login page, right? Okay, now why we are showing login page here? I entered a true, but why it is showing show login page? Why it is going inside else? Let's see. Let's try to execute it again. Sorry, my bad. Let's clear it out. Let's say if I give 1, what will happen then? Now it says show profile page, right? So when you're taking the user input for boolean, this is how you take the input, right? So if the boolean value is true, you show profile page. Let's execute it again. If the boolean value is false, that is user credentials are false, right? You are going to show login page, and that's consistent with our Netflix story, that what happens in the Netflix user journey. But there can be apart from just two conditions. So here you can see if the user give correct input, you show this, otherwise you show this. So there are like two branches, but maybe we can have different branches, right? So let's say based on the profile page, now maybe you can have three situations, and let me even put it here in between. Okay, so based on the profile page, we can have three situations. Let's say if the user selects children, we might show this. Okay, if the user selects Sanket, we might want to show this. And if the user selects Singh 14, then we might want to show this, something like this. Okay, cool. So what's going on? If we select Sanket, we want to show this. If we select children, we want to show this. And if we select Singh 14, we want to show this. Now there are three different situations that can happen based on the decision that the user is going to take. If the user clicks on children, we want to show this particular page. If the user clicks on Sanket, we want to show this particular page. If the user clicks on Singh 14, the user select this particular page, right? And this can happen with other apps also. For example, let's say you have Hotstar, right? If I take the example of Hotstar, so Hotstar is also a streaming application, right? And in Hotstar, you can buy different type of accounts. In Hotstar, you can buy different type of accounts. For example, you can buy, let's say, VIP account, right? Or you can buy a premium account, and there is like one more account that you can actually buy. So if I open Hotstar plans in front of you, right? So you will be able to realize one very interesting thing. So if I show you Hotstar plans, right? So you can see there can be a super, a premium, right? A super and a premium, and there is something called as VIP also, as far as I know, right? There is something called as VIP subscription also. So there can be different tier of subscriptions, right? So let's say if the user is a VIP user, if the user is a super user, or user is a premium user, based on different situation, that whether user is a VIP user, or whether the user is a super user, or whether the user is a premium user, or user is a free user, based on different situations, can I say we are going to show different content to the user? If the user is VIP, everything is, I guess, in Hindi, and only few basic things are there. Then in super there are few more things. In premium there is like everything with best quality, and in free technically you can just scroll, you can just see the shows, like posters and everything, but you cannot play the shows. So here you can see we have even more branches. Like based on what the user are, you have to do different things. So you have to take a decision. Hotstar as an app has to take a decision based on what is the user subscription status. Similar thing here. If the user clicks on this, you have to show this. Otherwise, if the user clicks on this, you have to show this. Otherwise, the user clicks on this, you have to show this. Now, what you can see, there are different branches that can go on. That means we can have multiple conditions that can actually happen. So how to handle multiple conditions that can lead to multiple branches? So for that we have something called as elseif. Elseif. So what you can say is that if user is VIP, then you are going to show VIP content. Then you say elseif, because if the user is not VIP, the user can be super, premium, or free, right? So we cannot just say else. We cannot just say else. It makes more sense to say else if user is super, and then you show super user content. Else if again user is premium, then you show premium content. Now you can see I have checked whether the user is VIP or not, whether the user is super is not, whether the user is premium or not. If let's say user is neither VIP nor super nor premium, if the user doesn't lie in any one of these categories, then definitely user is a free user. So we don't need to write else if in that case, we can just say else. Free, free user. Right. So free user will be seeing free content. Right. So this is the use case of if else if, that after a if block you execute else if. So how the execution is done? If this condition is true, we are going to execute everything inside if, and remaining everything, all the else if, all the else's are going to get blocked. They are not going to get executed. Let's say this condition was false. You came here, and this else if condition is true. That is, the user is a super user. So you're not going to execute the if block, and you will not execute any other else if or else block. You will only execute this block. Same thing here. Let's say user is not even a super user. This is also false. Let's say this is also false. But this is true, that user is a premium user. Then you will not even execute if, not the above if else if, and not the below else. Only this particular else if will be executed. And if let's say all the statements are false, then all of these are going to get avoided, and only the else statement is actually going to get executed. This is the most important point. And one more important point that you need to keep in mind is that the if statement can exist alone. You don't need to always keep else along with if. You can just have a if. That's it. But you cannot just have a else. You cannot just have a else. else will only exist with a if. Similarly, else if will also exist only if there is a if, then only you can put else if. You cannot start with a else if. This doesn't make sense, right? So else and else if cannot exist without if, but if can exist without them, right? So if I try to demonstrate this, let's say if else if demo one dot cpp. So now bool is user VIP, or let's say uh, we can do is user VIP, then bool, let's say true, right? Is user super, let's say false, bool is user premium is equals to false, let's say. And now we say is user VIP, then we do std out show VIP content, else if is user super, show super content, else if the user is premium, show premium content. Otherwise, ask user to pay, right? So if you run this code, you can see we are showing VIP content. Let's say the user is not VIP and instead the user is a premium user. Let's say we make it true. If you run it, see, you're going to show premium content. Now you might think, what if more than two conditions are true? Let's say the user is a super user also. Although this condition will not happen, you cannot have two parallel subscriptions. But let's say I'm just demonstrating if else. What if this condition is also true and this condition is also true? In that case, the first condition which is true, only that block will be executed. Rest other blocks will be avoided if you run it. So you only show super content. Although super and user premium both conditions are true, but the first block which will be having a true condition will be executed. Rest all of the blocks are going to get avoided, right? And this can help us to actually make decisions, right? That let's say if you select the first profile, then you this first profile, then you're going to show this, second profile will show this, third profile will show this, and so on and so forth. This is how you can make decisions and put conditional statements inside C++. So we discussed about if, else, else if, right? And I told you about the Netflix conditions that can occur like for a real life application, how you can actually map things in your mind. Now let me give you one more use case, right? Let's consider the use case of Amazon Prime, right? Let's consider the use case of Amazon Prime. Now what's the use case of Amazon Prime? Let's see. So let's say there are two cases, that whether you are a premium subscriber of Amazon Prime or not, right? This is to something that I can directly relate to, that whether we are a premium subscriber or not, or let's say Amazon Prime subscriber or not, is Prime or not is Prime. Can I say that? These are the two conditions that I can directly see. Okay. So if I have to like implement a screen like this, that whether the user has subscribed to Amazon Prime or not, there is going to be a simple check. What is going to be a simple check? You can say if user is a Prime member, right? If the user is a Prime member, then you will do something else. You can just say cout, please buy the Prime subscription. Okay, we are going to although show this message on the screen. We are currently, I'm doing cout, that means it is going to print it on terminal, but we are going to show it the message on the screen, but this is just for demonstration. Okay, now in prime the situation is not as simple as that. If you have ever seen this tab of prime video channels, then there are like other subscriptions that are available inside prime, right? So if you have ever seen something like this, you just scroll your prime videos, you prime video channel, you scroll them, and you'll get something like Lionsgate Play, you'll get something like Discovery Plus, Eros Now, right? And then there are more. For example, I guess there is something like Docubay, I Wonder. See, something like Docubay and I Wonder, right? What are these? These are internal subscriptions, right? When you buy a prime Amazon Prime membership, it's not like the 100% prime membership includes, or like the prime membership includes 100% of the content. Some of the content is also present inside these sub channels, some private video prime channels, right? You have to buy their different subscription. For example, you have to buy a different subscription for Discovery Plus, you need to buy a different subscription for Eros Now, you need to buy a different subscription for Lionsgate Play, you need to buy a different subscription for Docubay, you need to buy a different subscription for I Wonder, right? Now considering that, let's consider the use case of Docubay. Okay, something like this. Let's say I click on Docubay. Now I'm already a prime member. That's why I'm able to see the screen. Otherwise it will just say that go and purchase or something, right? I'm able to content, that's why my continue watching tab and everything is coming up. Now if I click on Docubay, let's say if I click on Docubay, then what will happen? Now there can be two cases. Either I am a Docubay subscriber or I am not a Docubay subscriber, right? So currently I am not a Docubay subscriber, right? Currently I am not a Docubay subscriber. So let's see how things will look to me. Or let's even consider the use case of Lionsgate Play. I have the screenshot for Lionsgate Play here, right? So a screen like this might come up, right? Let's remove this and get Lionsgate Play. Okay, let's say if I click on Lionsgate Play, I don't have the subscription currently for Lionsgate Play, so it is going to check is subscribed to Lionsgate Play, right? Then you are going to go to this screen, right? Let's say, and when you click on something here, let's say if I click on this, it is going to show me a screen like this, right? That how do I watch this? It is not going to let me play. It is not going to let me play because subs I'm not a premium subscriber of Lionsgate Play, right? So you can see within this condition of if user is a prime member or not, we have more condition that whether the user is a prime, whether the user is a premium subscriber of Lionsgate Play or not, whether the user is a premium subscriber of Eros Now or not, right? Whether the user is a premium subscriber of Docubay or not. All of these internal subscriptions separately exist. So if I have to like map them, what I can say is that if let's say somebody clicks on that, so you'll say if user is a Docubay premium member, some condition like this, right? Now you can see what I'm doing within the if condition. Within the if condition of is user a prime member, I am nesting one more if condition, and not just if condition. I can put nested else if user is a Lionsgate Play premium member, right? And let's say then we say just else. Let's say we just offer two internal subscription, Lionsgate Play and Docubay, and then else we just say that if the user is not a Docubay prime member, or the user is not a Lionsgate Play prime member, then the user is just a prime member. They will be able to just consume the content coming on Amazon Prime, not on Docubay, not on Lionsgate Play. So I know this is a very simplified version of what exactly Amazon Prime actually does. But what I'm trying to say is, within an if, within an if, you can have another set of if else, and same thing with here else also, right? Same thing with else also. Inside else also, you can have a nested if else. So this kind of a structure is called as a nested if else structure, right? Where within a condition you put more conditions, whether within a condition you try to put more conditions, right? Based on different use cases, you can get some cleaner way to implement these things based on the use cases, right? But for the time being, you can say that whenever we will be having a condition that, or whenever we will be having a situation that within a condition you need to put a bit of more conditions, then you can put this. Now you can ask me a question that maybe the user is a subscriber of both Lionsgate Play and Docubay, right? So you can even put that condition that user is a subscriber of Docubay and user is a subscriber of Lionsgate Play. And then you can put, let's say user is just the subscriber of Lionsgate Play, or the user is just the subscriber of Docubay, or user is not even the subscriber of any sub channels, it is just the subscriber of Prime. So like any level of complexity you can add, but my point being that you can like nest one if inside another if, if else another inside another else, or else if. All of these nested structuring does exist, and we can definitely use them. So based on of our knowledge of if else, we can start doing some problem solving. This is the first question in front of you. You have been given a number x, and you have to check if the number is even or odd, right? Whether the number is even or odd, you have to check that. For example, if the value of x is equals to 15, you will print odd. You will print odd. Okay. How can we do this? Now, can I say that any number x becomes even, any number x becomes even based on one simple condition, that it should be completely divisible by 2, right? For example, let's say 16. If you divide 16 with 2, you get 2 8s are 16, right? That means 16 is completely divisible by 2, and hence 16 is an even number, right? So actually the property of even or odd is based on the fact of divisibility, that whether the given number is completely divisible by 2. So the question boils down to the fact that how to check if x is completely divisible by 2 or not. How to check if x is completely divisible by 2 or not. Now divisibility can be checked based on remainder. Divisibility can be checked based on remainder, that if we divide x with 2 and remainder remainder is 0, then we say that x is even, otherwise x is odd, right? Otherwise x is odd. So if we try to divide x with 2, then the remainder should come up as 0, and we directly have an operator that can help us to detect the remainder. Can I say that? So we have the modulo operator. So what we can say is that we can do x mod 2 in order to calculate the remainder. We'll do x mod 2 in order to calculate the remainder. So what will I say? If I draw a clean flow chart for this, so we'll just start the program. We will take the input of x. Can I say that? We'll just take input for x, and then we'll do a condition. Then we will do a condition that is x mod 2 equals to 0. There can be two outcomes, either a yes or a no. If it is a yes, then we will do something, otherwise we will do something. If it is a yes, then we will say output even, otherwise output odd, right? And then we can just stop the execution. Right? This is the basic flow for the flowchart, that we will take the input for x, and then we will check if the x is divisible by 2 or not. If x is divisible by 2, then we can say it is going to be an even number, right? So if I just try to quickly code it, even odd, right? So we'll say hash include iostream using namespace std into main, return 0. First of all, we'll create a variable x, int x, right? We will take input of x, so we'll say c in x, and then we'll say if x mod 2 is equals to 0, then we will see out even and a new line character, else we will see out odd with a new line character. That's it. As simple as that. If you run this code, it's going to expect some input. Let's say if I give 7, 7 is odd. If I run it again, if I give 8, 8 is even. As simple as that. So using this basic piece of code, we will be able to detect whether the number is even or odd, right? But this was using the division. This was using division and checking whether divisibility works for us. But during number system, I told you one more logic. Let's say if I write binary of a few numbers, so these are the binary of the given set of numbers. Okay, and if you check any even number, all the even numbers, if you carefully look, the last bit of all the even numbers are 0, right? So we can say last bit of all even numbers are 0, right? So if we can check what is the last bit, then we can detect if number is even or odd. Can I say that? Right. If you have to detect that whether a given number is even or odd, what you can do is you can try to check if the last bit is 0 or not. If the last bit is 0, then the number is even, otherwise the number is odd. How can you check what is the last bit? What is the last bit? Now just think about it. Let's say I get a number x equals to 9. What is the binary of 9? 1001. I just care about the last bit. So technically, I need to somehow eliminate all of the other bits. I don't need other bits. Whatever are their value, I don't care about them. I just need to focus on the last bit. Okay. If you see the number 1, then technically 1 is the number in which Everything else is technically 0, only the last bit matters, right? And we know about an AND operation. We know about an operation of AND, bitwise AND. This is bitwise AND. Using bitwise AND, you can do AND operation bit by bit on any two numbers. So if I do X bitwise AND with 1, what will happen? 1 is 0, 0, 0, 1. If you do a bitwise AND, 1 and 1 is 1, 0 and 0 is 0, 0 and 0 is 0, 0 and 1 is 0. So what bitwise AND will do is, because 1 is having all the remaining bits as zeros, doesn't matter what your number has in the remaining bits, it will convert all of them to 0. Can I say that? See, if let's say I have 9, I need to eliminate these 3 bits. If I do an AND with all zeros, then doesn't matter what you have in these bits, all of these bits are going to get cancelled out. Can I say that? All of these bits are going to cancel out. Can I say that? Right? And then at last you will be having this last bit. At last you will be having this last bit. This last bit will be done AND to the last bit of X. Now if the last bit of X is 1, then 1 and 1 will be 1. If you consider something like 8, X is equals to 8, then 1 triple 0. If you do a bitwise AND with 0, 0, 0, 1, can I say all these bits will be cancelled? And now you will check the last bit. Last bit of X is 0. 0 and 1 is 0. Can I say that? So my point being that if you do a bitwise AND with 1 of any number, there are only two possible outputs. Either the final answer will be 1 or the final answer will be 0. See, if you do bitwise AND, you got a 1 here. You did a bitwise AND, you got a 0 here. If by doing bitwise AND, you got a 1, that means it was an odd number. Otherwise, it was an even number. Let's take any other example. Let's say 15. The binary of 15 is 1, 1, 1, 1. Now you need to eliminate these 3 ones. You do a bitwise AND with 1. So because 1 has 0 all over here, doesn't matter what you have these bits in 15, everything is going to get cancelled out and everything becomes 0. Now we just focus on the last bit. Last bit of 15 is 1. 1 and 1 is 1. That means if you do 15 and 1, it becomes 1. That means 15 is an odd number. Can I say that? As simple as that. So I can make another file. I can make a variable x. I can take the input of x and I can check if x and 1 is equals to 0, then the number is an even number, else the number is a odd number. Can I say that? Right. Let's just put a return 0 here. If you run it, right, it's giving us a warning that we should bind it inside parentheses. We can do that, but warning doesn't hamper the execution. If I put 5, 5 is an odd number. If I put 6, it says 6 is also odd number. So what is the problem here? We need to bind it inside the parentheses. Otherwise, it is not going to do it. Otherwise, it is not going to like return the computation. So if you run it now, see now the warning is gone, and now we put 5, 5 is odd. Now you put 6, 6 is even. Let's say 15, 15 is odd. 99, 99 is odd. 100, 100 is even. So these are the two ways in which you can just detect even or odd. Just make sure whenever you are using a bitwise operation, bind it inside parentheses. Otherwise, it just starts doing the computation from the last number sometimes. Just do bind your bitwise expression inside a parenthesis and everything should be fine. So this is another way in which you can detect whether the number is even or odd. So to make our understanding more clear around if else, this is one more problem in front of you. So we are given 3 numbers A, B and C, right? So you will be given input of 3 numbers A, B, C. Okay, you will be given input. User will be giving some input. And you have to check if you can form a triangle using the side lengths as A, B and C. So will you be able to form a triangle such that the sides of the triangle are from A, B and C, right? So you have to detect whether you can form a triangle using these three as the side length, right? The order doesn't matter. You can have the side length as C, A, B, something like this. The order doesn't matter. It's just that every side of the triangle should be either A or B or C. So you have to detect whether you can form a triangle or not. Yes or a no question. It's a yes or no question. You don't have to draw the triangle. It's just a yes or a no question that if I want to keep the side length of the triangle as A, B and C, can I form a triangle? For example, if I want to keep one side as 7, one side as 10 and one side as 5, so that I give the input of A, B, C as 7, 10 and 5. So the answer should be yes, that yes, we will be able to form a triangle such that one side of the triangle is 7, one side is 10 and one side is 5. We will be able to form a triangle like this very easily. Whereas if I give you one more test case in which I ask you to keep one side as 1, one side as 10 and one side as 12, so you won't be able to form a triangle and hence the answer will be no, right? So you will be given three numbers. So you have to take user input of three numbers and you have to detect whether you can form a triangle or not using the side lengths as these three numbers. How can you solve this question? It's a very simple question if you remember basic mathematics. If you remember basic mathematics, then this is going to be an extremely simple question to solve. Okay. Cool. Now let's say that we have the sides as A, B, C. Right. These are the three sides of the triangle. In order to form a triangle such that one side length is A, one side length is B, and one side length is C, we need to satisfy three conditions simultaneously. We need to satisfy three conditions simultaneously, right? For each side, for each side, the sum of other two sides, the sum of other two sides should be greater than the current side, right? So you have to do this thing for each side. So you have three sides, so it will give you three condition. What will be the condition? That the sum of the other two sides, for example, if I consider this side of A, then the sum of B and C should be greater than the current side. That means B plus C should be greater than A plus B should be greater than C, and A plus C should be greater than B, right? So these three conditions need to satisfy together. That is for each side. The sum of the other two sides, so B plus C, should be greater than the current side, that is A. If you consider this side of B, then the sum of other two sides, A and C, sum of A and C should be greater than B. If you consider this side as C, then the sum of should be other two sides should be greater than C. If all these three conditions satisfy together, then only you can form a triangle. For example, let's say 7, 10 and 5. If I keep this side as 7, this side as 10, this side as 5. Okay. Now you have to detect the condition. Let's check for the side 5 first. Let me write the sides inside. Okay. Let's check for side 5 first. What is the condition? The sum of other two sides, so 10 plus 7 should be greater than 5. And can I say 10 plus 7 is greater than 5? 10 plus 7 is 17. Is 17 greater than 5? Yes. So this condition is holding true. Let's talk about this side, 7. The sum of the other two sides, that is 10 plus 5, should be greater than 7, and 10 plus 5 is 15. 15 is greater than 7, so this is also satisfying. Let's talk about 10. So the sum of other two sides, which is 7 and 5, should be greater than 10. So this condition is also satisfying. And if all these three conditions simultaneously satisfy, then you can say you can form a triangle. Let's take one more example. If I try to form a triangle with 1, 10 and 12, although you won't be able to form, but let's see. Okay. So the sum of other two sides, let's move it inside. I'm just drawing it like a dummy. I've just drawn a dummy triangle, although you won't be able to form it, right? So for 1, the sum of the other two sides is 10 and 12. So is 10 plus 12 greater than 1? Yes, it is greater than 1. First condition is good for us. Then for 12, the sum of the other two sides, 1 plus 10, should be greater than 12. Is 1 plus 10 greater than 12? No. 1 plus 10 is not greater than 12, and hence you don't even need to check the third condition. You cannot form this triangle. You cannot form this triangle. So what I can do is I can just put a simple if else check. I can say if a plus b is greater than c and b plus c is greater than a and a plus c is greater than b. If all of these conditions hold true, then I see out a yes, else I see out a no. Because we want all these three conditions to be satisfied simultaneously. All these three conditions should be satisfied simultaneously. It's not like one condition is false, rest are true, still it is fine. No. Every condition should be true. If I want all the conditions should be true, the best way to measure them is going to be an AND operation, right? So if I write a piece of code in front of you for this, is triangle. Okay. So I'll take an input from the user, A, B, C. We need three variables. I can take input like this, A, B, C, right? We can chain the inputs. And then I can write the condition. If A plus B is greater than, if A plus B is, let's say, greater than C, and B plus C is greater than A, and A plus C is greater than B. Okay. All of these conditions, and I'll bind these condition itself in parenthesis. It's always a good practice to keep things segregated in parenthesis. That you can just select the whole expression and just put the opening parenthesis, it will automatically put the closing one. Then we can say a yes. Else we say a no. Okay. Cool. If you run it, it's expecting input from us, right? If let's say I give the input as 5, 10, 7, the answer is yes. If I give the input as 10, 12, 1, the answer is no. So using this simple if check, we will be able to detect whether the three numbers will be able to form the side length of the triangle or not. Okay. So this problem says that you have been given three numbers, right? You have been given three numbers. So we will assume that user will be giving input for these numbers. You'll be given three numbers and you have to calculate the minimum of the three numbers, right? So you have been given a number A, let's say equals to 2, B, let's say equals to minus 3, C, let's say equals to 10. So the minimum of all is minus 3. That's something that you have to do. Okay. How can you solve it? How can you solve it? In a very simple way. In a very simple way. Let me ask you a few questions. Let me ask you a few questions. If you have to check whether the numbers within the numbers, what is the minimum number of all. Now, can I say something like this, that in what case, A will be the answer? You tell me, in what case A will be the answer? Can I say, if A is less than B and A is less than C, in this case A will be the answer, right? If A is already smaller than B and A is already smaller than C, in this particular case only we can say that A will be our final answer. Just think about it like this. Let's say you have minus 12. So minus 12 is less than minus 3 and minus 12 is less than 10. So both of these two conditions are satisfying, right? So you only have three numbers to compare. You only have three numbers to compare, and your number A is already less than B and less than C, right? So we will say A is the answer. Can I say that? I hope this point is making sense to everyone. Meanwhile, let me ask you one more question. In what case B will be the answer? Can I say that you might answer it in the same way? That if B is less than C and B is less than A, then B will be the answer. For example, in this case, minus 3 is less than 2 and minus 3 is less than 10. Both of these conditions are satisfying, right? So for A to be the answer, this is the condition. For B to be the answer, this is the condition. If let's say both of these doesn't satisfy, then automatically C will be the answer. Can I say that? If both of the previous statements doesn't satisfy, then C will be the answer. Can I say that? So all you have to do is check if these two things are correct. Then if it is not correct, then check if these two things are correct. Otherwise C will be the answer. As simple as that. So what I can do is I can say if A is less than B and A is less than C, then A is your answer. Else if B is less than C and B is less than A, then B is the answer. Else C is the answer. As simple as that, right? And you can like segregate these conditions in multiple ways. You can even use nested if else checks also in order to answer this question. But like using just one if and one else if and one else is as simple as that. So if I try to code this solution, you can say minimum of all dot cpp. Okay, let's take the number of three. Let's take the input of three numbers C in A, B, C, and then we'll put the first check that if A is less than B, and we can use a logical AND like this or a logical AND like this. Anything should work, right? And A is less than C. In this condition, A is the minimum. Else if B is less than A and B is less than C, then we can see out B is the minimum. Else we can see out C is the minimum. See, that's it. That's it. If you run it, let's say you have 10, then you put minus 3, then you put 2, you can say B is the minimum. If you run it again, so instead of giving input in new line, even if you space separate the input, it is going to consider it as a new input. For example, if you are taking the input of A, B, and C, right? I'm giving input in three different lines. So it makes sense that first input goes inside A, second input goes inside B, third input goes inside C. If you put space separated, same thing. Then the first number is going to go inside A, second number is going to go inside B, third number is going to go inside C, right? It's not like the whole one single line goes in one variable as the input. If you have to put whole one line as one variable in the input, there is something extra that you have to do in C++. Otherwise, this kind of a syntax works for us. So if you press enter, you can see C is the minimum. And this is how you can calculate minimum of all three in C++ without using any internal capabilities of C++ by just putting pure simple conditional logic. So when you are going to start your journey with programming, you are going to get introduced to a lot of online platforms. These online platforms already have bunch of questions, like hundreds and thousands of questions, and where you can just go and practice, right? These platforms are something like Codechef. You can see something like Codechef. There is something like Code Forces, right? There's something like Code Forces, similar concept, minimalistic UI, and just question like, and you see if you just go to problem set, it's like an endless problem set almost. See, 83 pages, every page has like what, 50 odd questions. So it's like tons and tons of questions. Then there are platforms like HackerRank. There is a HackerRank named platform also, right? This is also a platform where you can like go and practice, right? Then you have a platform like LeetCode. A lot of people use this platform for interview preparation. It's specific. LeetCode is specifically for interview preparation. If you want to prepare for interviews, you can just go to LeetCode and like start solving questions and everything, right? So my point being that you don't need to like figure out what questions to solve in order to get your hands dirty on coding. You have a bunch of platforms using which you can do all of these things, right? We are going to use these platforms in order to solve questions. And let's say I can start with Codechef. Every platform has 90% of the nuances as same. Some of the nuances are different that maybe we can actually talk about. So this is the problem on Codechef named as if else problem. It's a very simple question. In most of the platforms, you will be given a problem statement. So let's read our problem statement. And it's generally very clear. Given an integer n, you have to perform the following conditional actions. If n is odd, you have to print weird. Okay, if n is an odd number, doesn't matter what is the number, you have to print weird. If n is even and then it is in the range 2 to 5, you have to print not weird. If n is even and it's in the range 6 to 20, you have to print not weird. And if n is even and it is greater than 20, then you have to print not weird, right? This is the problem statement. So it explains what is the intention of the author, that like what the author wants you to code, right? Author of the problem. They also give you input format, that how you have to read the input from the user. You have to just read a single line containing one positive integer. So you'll be just given one integer as the input. For example, if you have been given 17, you have to print weird because it's an odd number. Sometimes you will also see this section of constraint. So it is going to tell you that how big a number can be. How big a number can be. Okay. So how can we code it? How can we code this? There will be multiple ways to solve the same question, guys. It's not like you are only going to have one particular way to solve a question. But first of all, let's try to take the input of a number. So let's say if we say int n and we say c in n. This is how we take input of a number in C++. This is how we are going to do it here as well, because you can see C++ is selected. Can you see that? And then what we can say is that if n is odd, you have to print weird. Otherwise, you have to do something like this. So let's say if I do, if n mod 2 is equals to 0, that means n is even, then we have to do something else n is odd, right? Else n is odd. If n is odd, you have to just print weird. So I'll see out weird. That's it. Right? Spelling is wrong. Weird. And then if n is even, then you have some conditions. That if n is in the range 2 to 5, if n is greater than or equal to 2 and less than or equal to 5, then you have to print not weird. See out not weird. It's a text, so we'll bind it as a string. Else if you n is in the range 6 to 20, n is greater than or equal to 6 and n is less than or equal to 20, you can see out weird. You have to print weird. And if n is greater than 20, if there is anything greater than 20, that means else, and you have to put else if n is greater than or equal to 20, then you can see out not weird. Now you might be thinking why I didn't put else, because maybe n is 1. Maybe n is 1. If n is 1, then this condition doesn't satisfy, right? Although it will be already caught here because 1 is what, an odd number, right? But still I can just put it a separate else if. You can even put a separate else if you have logically considered that after line number 8, if in case of 1 you will just directly print 0. Okay, now let's say we wrote some piece of code. I don't know whether it is correct or not, and now you want to test it. So you can test it on some custom input. For example, you can give your input here. If I write 17 and do compile and run, so it's going to take up some time. It's not going to be as fast as your system because it's going on inside over the network, but it's going to do the work for you. It says successfully executed. So execution went well. It doesn't tell you whether the output is correct or not because you have to that manually check, but you can see the output is this. Now if you have to see whether your code is correct or not, what these platforms like Codechef and Codeforces has internally done was, they have a lot of test cases internally on their servers. When you click on this button, submit code, when you click on this submit code button, what will happen is you are going to actually submit the code. You are going to actually submit the code on the actual platform. And then what will happen? What will happen is you are going to get compared. Your code is going to get compared with other folks code, right? Which is like not other folks code, but let's say the internal test case of Codechef, that whether everything is working fine or not. If let's say there are some cases for which your code will not work, it will automatically detect that. So we are going to test it. So now if I try to click on submit code, see it is submission queued. It is going to take like 10 odd seconds, I guess. We have to wait for the submission to work because, as I said, it's going to work on not on our system, but actually it is going to go to Codechef servers and then compared with all of the test cases. See, it's running on test case 2. It will tell you the status also, and you can see it says 1 day streak. You can just close it, and it says correct answer. Correct answer means everything went well. Everything went well, and you have solved this question correctly. If let's say I make some mistake, for example, if I make a mistake like instead of weird, I say weirdo. Let's say by mistake I pressed a O, and then I try to submit the code. It is going to get submission queued again. It will run on a few test cases, and see, it will tell me the wrong answer, right? On few platforms, it will also tell you for which test case you got the wrong answer, but in Codechef, it will not tell you for which test case you got the answer. On lead code and all, you get the test case also for which you got the wrong answer. Now, if you correct it and submit it again, see, correct answer. So that's how you actually like practice problems here, right? Now, this is one way to solve this question. Like I can just quickly paste it in VS Code. Weird Codechef 1.cpp. Right, I'll just paste this code so that we have it for reference. But if you will take a look here, the code looks a bit cumbersome. Why? Because you have a if, then inside an if you have a nested if else, right? The code looks a bit cumbersome. I can reformat the code a bit. So whenever you have like a bit of nested if else, I'm telling you with respect to software engineering practice, right? Most of the time, whenever you will be learning basic programming, in your initial days, no one is going to tell you, because in your initial days, it doesn't matter. But as I said, as I always say, you should not learn for just preparing for interviews. You should learn for becoming a better engineer, right? So as a better software engineer, your duty is not just to write code and solve problem. Your duty is also to write clean code. Okay, clean code is something very important. So if you take a look at this piece of code, if you take a look at this piece of code, it's not that bad, but it's still having some nesting, because if someone has to read it, you need to take up some time. What we can do is we can write the conditions like this. If we say if n mod 2 is not equal to 0, see out weird. Now you tell me, if after line number 8, if at line number 8, if a user reaches line number 8, then you will be saving one condition call here, right? You don't need to go inside this, although if it will be odd, it will never go inside, it will directly come here. But you are saving one if else. Why you are saving one if else? Let me show you. Because just think about it. If your user is coming to line number 11, if user is coming to line number 11, that means that the above number was already even, right? That's why you were not able to satisfy the condition on line number 8. That's why you reach line number 11, right? So what you can do is, the moment you print weird, you can just return 0. That means what return 0 is going to do, it is going to exit the program then and there, right? So if the number was odd, you print weird and you exit the program. See, this is going to help you to exit the program. Although the return 0, it's not exactly just going to do exit the program, it does a bit more, but we'll understand all of those nuances later. I'm just showing you how you can write cleaner code. Now, here you can just directly check these conditions. You don't need to check about n mod 2 equals to 0, because we know if we have survived line number 8 and we reach line number 12, that means we are even already. So you can say we are already even. So you don't need to check. You don't need to put a check there. Right? Okay. Now just think about it. Here also you have if, else if and else. Now you can just do something like this. If let's say your value is greater than or equal to 20, then you can just see out weird. Right? You can just see out weird. If the value is greater than or equal to 20, there is no other case that can happen, right? And you can just say return 0. See? You can just say return 0. And even if you don't say return 0, then at least one else if condition should be fine, right? So just think about it. If the number is greater than or equal to 20, you have to print not weird. First of all, you have to print not weird. And in any other case of 2 and 5 also, in 2 and 5 also you have to print not weird. So what you can do, you can put a and, you have to put or. So we'll say or n is greater than equal to 2 and n is less than equal to 5. Then also you can print not weird. See, this either this condition should be true or this condition should be true, and then you can just do a return 0. Otherwise, in every other case, you just print weird. Right? See out. You don't need to put a check. In every other case, you just print weird. Right? Let's try to test it with some test cases. Okay. So let's say if you run with 17. Okay, 17 is odd, right? So we are already going to get correct answer weird, because it is going to be caught here. If you do 16, 16 comes inside weird. 16 should give you weird, right? So we are getting correct weird. If let's say you have 21, or let's say 22. See, for 22, we are getting not weird. Why for 22 we are getting not weird? Because if the number is even and greater than 20, we should get not weird. So let's try to submit. Looks like fine. Looks like fine to me. If you try to submit it and see correct answer. And if you take a look at this piece of code, if you take a look at this piece of code, if I just copy paste this here, weird code chef 2, right? And if I simultaneously compare, then if you take a look at both the programs, if you take a look at both the programs, the second one looks cleaner, right? You just have two if conditions. Here you have a if, then inside that if you have a if, then else if, then else if, then you have an else. For the timing, we don't have any nesting. For the timing, we don't have even any nesting, right? I just tried to put the conditions in a new way such that you are able to filter out a major chunk of data in one go. And you do something like this. And for the last condition, you don't even have to like print anything, like do a conditional. You just did see out weird. The new part that we introduced was that we are adding return 0 at multiple places. This is we are doing because we just want to exit the program then and there. Later, when we will understand the concept of functions, you'll be able to understand the concept of return statement in much more depth. But again, as I said, in your initial days, everyone is going to teach you this, and it is totally fine to know just this kind of a code. But as I said, we want to be better software engineers. At any point of time, if we detect that the code looks a bit cumbersome, at any point of time, if you feel your code is looking cumbersome, then 99% of the time there will be a better way to write it. Trust me, when you go to companies, when you work as a at the, let's say, top 10 startups of India, top 10 startups all over the world, top 10 big tech giants, fang, anywhere you work, open source, wherever you work, when you are actually into the company, for getting into the company you need to learn a lot of like optimization on the code and everything. But when you actually start working as a software engineer, I'm talking about that particular piece of life, then writing optimized code is your second priority. Your first priority is writing cleaner code. Cleaner code is always the first priority. You are going to, let's say, if you wrote an unoptimized code, then your manager is most probably going to say that, okay, let's, in your version 1 of your product, let's go with the unoptimized version, and maybe we can optimize it later in version 2. Let's get things going. But if you'll write bad code, if you'll write ugly code, then they are not going to push your code like in version 1 also. So writing cleaner code is more important than writing optimized code once you get into the companies. For getting into the companies, people expect you to know optimizations and everything. So that's kind of like a bit weird, weird thing that goes on in the software industry. But like that's like something that I'm telling you with my experience, that people expect you to write cleaner code always and always. So I hope the logic of this problem of weird is clear to everyone. So I hope you guys enjoyed this lecture, and if yes, then don't forget to drop a like and share us your thoughts in the comment section below. Do let us know if you want some specific videos on the channel that you are specifically looking at, maybe some guidance or some specific technology you want me to explore. Do comment that. We will definitely try to include that on the channel. That being said, let's just wrap this video here. We are going to meet soon in the next set of lectures. Till then, take care, guys. Bye bye. I'm Sanket Singh, signing off.